Hello there, everybody, and welcome to this Learn Live encounter that we're going to have. Both Tom and myself are here for you. And for the next hour to an hour and a half, we're going to be guiding you through one of the modules within the Microsoft Fabric Learn Together series, where we can actually go through with you all the different technologies that are necessary for you to try to really get through your DP exam, DP 600, I believe, Tom, correct?
Yes,
Exam.
sir.
So we're really looking forward to this engagement with you. Firstly, I'll quickly introduce myself. My name is Charlie Hanania, Data Platform MVP out of Switzerland. Basically a data platform specialist for many years. Happy to use Fabric, happy to use all the different database technologies. And now on to you, Tom.
So Tom Martens, working for an insurance company that is based in Munich. I am also a data platform MVP, Power BI, Microsoft Fabric community super user, and I'm really happy and excited that I'm be part of this because I have to admit that I'm a fanboy of Fabric, so very pleased to be here.
Great. Now, we come from a bit of a different background, Tom and myself. Mainly you're on the analytical side. I come back from OLTP, from my earlier days in technology and databases. We aren't alone here, though. We have on the live stream with us here in the background, we have Nikki and Bernard, who are both data platform MVPs as well, both experts on the platform, and they will be fielding your questions and bringing some of them up to us as well if there's relevance for the whole group. Now, feel free to say hi to them, tell them where you're from, and basically it'd be great to work out the different countries and places that you're all shouting out from. So, Tom, basically, let's take a look at what we're going to be covering today. There's basically a module within the Learn series on the Microsoft website, and it's focused on working with Delta Lake tables within the Microsoft Fabric experience or environment. There's a QR code you can see there on the screen, and if you want to run through it with us as we're talking through these slides, feel free. So use that QR code. It should take you to the website. Or if you go to that aka.ms link there, that'll help you as well to get to the same place that we are. This will probably also bring you to our video, our live stream, but feel free to take a look. There should be links in there for you as well. So don't feel shy. This is the time for you. It's the time for us to really help engage with you. And we're really hoping that you have lots of questions and lots of interactions with both ourselves, Tom and myself, and also the moderators there as well, where we've got experience in the platform and also with the exams. So feel free to basically ask any questions you need over the next hour to an hour and a half, and we'll see if we can get through to all of your questions as well. First thing we want to talk about is a website. Okay, this is called the Fabric Career Hub, and you can get to it through this aka.ms link. And on that journey, basically, it helps you understand what it means to be an analytics engineer, as well as other analytics roles as well. And there's a series of interviews in there, a lot of videos, people who are in the industry, how they've experienced it, and so forth within the Career Hub. And it gives you a lot of insights in terms of the sort of things you can expect when you're on this sort of a journey. Now, Tom, you've had an analytics hat and different hats, I guess, for a long time. Can you talk to us about this other part of the same webpage?
So sometimes I find it difficult to explain what are exactly the differences between an analytics engineer, a data analyst, a data engineer, because basically, if you click through this on the Career Hub site, you will see they are tasked a little bit different. So I basically wear the first three hats. So, and this is also the reason why I'm consider me being next to Fabric Sherpa. I'm also consider me being a data barista, because I serve data in various forms so that people can get insights from that data. And this DP 600 that is all these Learn Together series about is a broad certification. So this means a lot of areas might be covered that you are not familiar with that. So, but please don't be shy. I guess this series prepares you for a lot. But it's also important, I guess, that you not get confused by these tasks. Find something that you are passionate about this and focus on that. So, and then maybe you will become an analytics engineer or a data analyst, or maybe both, because it's there's overlap. And with this said, please go ahead, Charlie.
Yeah, so I mean, as you said, Tom, sometimes you're wearing different hats, and I understand that completely. In the roles that I've played within different environments, there's no clear transition, but it's great to know that there are different opportunities out there in terms of what Microsoft is also doing through its role-based learning and role-based certifications. Now, what you'll see here, and what I think Tom was saying as well, is that all of these sort of gray boxes here are sort of the focus areas that are within this exam. And the exam itself, what we're going through with you is a taster of all that. We don't expect that once you've watched the series that you can go and attend the exam and try to sit it and pass it. The expectation is play with them, allow us to whet your appetite in terms of understanding some more of these technologies and diving deeper, getting more experience with them. And then through some of the other activities that we're going to be talking through, find your way into the right role and so forth. But as Tom's in the industry and he's working in that for quite a while,
Yes.
I definitely take Tom's advice with very high credibility there.
So I cannot reveal how long I'm working in the analytics industry, because it will also get a glimpse into how old I am. So
How young
I will not be able to retire tomorrow, but it's
I think the standard is 21 plus a couple of years experience or something like this, right? As in age. So moving on to the journey of what we're going through here. On that same webpage that we saw, that aka.ms link, you're going to find another section, which is the certification journey. Basically, the concept there is to help you through, given a number of different resources that are online or in person, such as this, where you can actually find your way through to becoming a person who is credibly capable of actually implementing these things in the workplace. So one of the first steps here that's listed here is the Cloud Skills Challenge. And I've linked to that here too on the next page. It's time bound in terms of doing it. And once you've actually gone through all of the modules, these ones included, you'll get a 50% exam discount voucher that you can use to actually do your DP600 exam. So watch out for that, and you'll see that on the same page that we're discussing now. And then what we're working on today is this Learn Together section. So the Learn Together section basically is walkthroughs of each of the major areas and major modules that are going through. There's 9 of them in total, and we are number 3 of that. So hopefully you've had a chance over the past week or so to see all of the other ones, starting from the beginning of this week, actually, for CET, for Europe and India, that you're able to basically sit through the Learn Live sessions and get an idea of some of these examples and some of the theory behind it as well, so that together with us and that in a way that you're able to actually replay and dig deeper into some of these technologies, you're able to get through the modules in an easier fashion than just running through it on your own. Again, there's the QR code that you can use. This is us. And next Tuesday, the next one starts as well, which is Data Factory Pipelines, which now that we're talking about using Delta Lake tables here, I'm sure that ingesting those and transforming those will be quite interesting for you next week as well. So that's us here at the moment in the Learn Live session as well. But on top of that, Microsoft has given more stuff to help you get through your exams and to understand the technologies better. And that is an exam cram. So for the DP600 exam, next week, or in the coming week, sorry, in 2 weeks' time, May 8th, there's going to be a instructor-led exam cram where there'll be MCTs and MVPs basically available to you, that you'll be able to ask questions of. They'll talk through what the exam is like, what to expect, what the skills are that are measured, all those simple things that you're able to get a lot of information from very quickly from these people who have either written part of the exams or have set these exams themselves, so that you're able to really prepare yourselves well for the exam once you get to it. Tom, what do you think? Should we head into the learning objectives for what we're covering today?
Let me think about it. Yes.
Yes. Okay, good. So what we're going to be covering today is the concept of what the Delta Lake is, okay, how it sits on top of the data lake, and what Delta Lake tables are inside Microsoft Fabric. We're also going to take a look at Delta tables and how to manipulate them or use them and create them using Spark and other methodologies that Tom will walk you through as well. We're going to take a look at how to query and transform that same data that you might be creating either externally or, oh, sorry, I shouldn't be saying that yet because that's Tom's part of it later. But basically how to use the data that we've created within Fabric in these Delta Lake tables. And then talking about something that's part of one of the general architectures that we talk about, which is in a Lambda architecture, which is streaming, because generally when we're talking about analytics, we're talking about batch. So we're going to look at how you can use Spark structured streaming with these Delta tables as well. So first thing is understanding a bit of what Delta Lake is. Now, in the days prior to big data, okay, we've got a lot of different database management systems out there, which would be using proprietary data formats to actually store data, usually in those days, and still till now, in row formats, okay? But what Delta Lake gives us is another storage layer on top of the data lake, which gives us something called relational database semantics on top of these data lakes, which allows us to process data in a little bit of a different way and gives us capabilities that we didn't have in the past on the data lake. Now, when we're taking a look at it, what we're going to be diving into is the Fabric environment. So if you haven't seen it, make sure you take a look at the previous videos and previous Learn Live sessions that have been there. But basically, the idea here is that within the Fabric lakehouse, you've got different capabilities there. You've got tables, you've got files that you can link to, and as you can see here, you can see those tables in some sort of a row-based format as well. But when you are actually looking at the way that those files are stored in the background, when it's data lake, the Parquet data structures that we're using is backed up here with a directory for what we call a transaction log, which if you've worked in relational database systems before, you'll understand. But the transaction log itself is the magic behind putting a lot of these ACID-based technologies or these relational database semantics, as we call them, into this data lake capability. What you'll see here as well is a series of other Parquet files which are available to us, which are actually the data that gets uploaded into or added to the tables that we're talking about as well. So these are Delta Lake tables, which are sitting on top of what we know on the data lake, which are usually based on Parquet files and other formats as well. But from what we're talking about mainly, we're talking about Parquet files as well. So a little bit about this Apache Parquet that I've mentioned a couple of times. So Apache Parquet is the foundation of what we use in what's called OneLake, okay, within Fabric. Let's talk about how things used to be stored and so forth. I've mentioned already that traditionally there are a lot of closed source proprietary formats that were used in the past for things like SQL Server, Postgres, etc., MySQL, etc., etc. And what is used in those days, or the way that things were basically stored, were here, as you can see, in rows. Okay, so within a certain row, there'd be lots of different. There'd be structure basically put on top of it, because when we're talking about transactional processing systems, we try to make sure that there's structure on it so that it's very quick and easy when we're inserting, updating, and deleting data, which are sort of CRUD operations, what we call. And because a row would have different data types, we would end up finding that the compression algorithms that we can play on them aren't all that optimized. So for SQL Server, if some of you come from the SQL Server history, around SQL Server 2008, a number of compression algorithms came in based on the row, where you could compress a row or a page, and it would bring some significant benefits from that perspective, because data or the storage subsystem was always seen as the slowest subsystem within any database management system. So if it's sitting here in a relational database, or if it's sitting here in things like a CSV file, which is a semi-structured data file, you'll find here that things would start maybe with the column names. In this case here, we might know what the data types might be for each of those fields, and then you'd have the row itself with a mix of different data types and data within there. For analytics, it's a bit different though, because in analytics, generally you're aggregating or filtering, or you're only asking for things in certain columns. So I might say, give me a count of the customers in a certain region. So I don't need to know the last names. I don't need to know the street names. I don't need to know different things in there on whether or not they're premium customers or not. And so when I'm doing this in a row format, I find that I'm actually bringing in more data than I need to use. And then basically that's a waste of memory, a waste of capacity, and the CPU is being used for reasons that we don't really need as well. So that's where Parquet format comes in. Parquet format is a columnar data store or file format. Okay, it's open source, which is different to what we were saying before in terms of these proprietary formats. And it was basically put together by Cloudera and Twitter in around 2013. So it's over 10 years old now already. And it's gone through a couple of revisions, but it's pretty much the standard for its used, especially on the Microsoft Data Platform and itself at the moment. But there are other formats as well. And if you go through some of the other courses, like DP 900, which is the fundamentals, Azure Data Fundamentals course, it talks about some of those other formats and capabilities as well. So always good to understand what other things are out there. And so I would recommend you look at some of those things as well. Now, this slide that we're talking through here tells us something else about how things can be stored. And as some of the relational databases also evolved to cater for analytics and so forth as well, like SQL Server, it brought into this whole space also the columnar compression and capabilities there too. Now, how does Parquet work? It works by basically not going row by row, but splitting your row-based data into sets of rows, and then within those sets of rows, taking the columns out themselves and compressing those columns. It does it in a couple of phases, or 3 phases mainly. It basically goes through and encodes a lot of those like-for-like columns. So for here, if we take a look at the first name, for example, you'll notice that they're all text-based, so you won't see any integers in this case. And for other ones that are integer or binary or bit-based, you'll have other different possibilities in terms of compression. So when data is similar, you'll find you'll get much better compression out of those sort of sections themselves. So that's the first thing that Parquet does. It tries to compact and compress the data for when it's coming in a sort of a column. And it does it in several stages. And then after it actually goes through and compresses the data that you've got in the row sections and then in the columns, it puts at the end of this file, this Parquet file, a section for metadata, which basically gives a lot of analytics or some summarizations and aggregations in terms of how those sections work. So how many rows were compressed in those row segments, how much storage is taken up in the columns, what the min and maxes are of the data that's in there, etc., etc. And these sort of things are done in that sort of a way, so it's very quick to write after doing all that stuff in memory and then writing it out. And then at the end, that summary helps Spark and other platforms really take a better view in terms of how to filter out if necessary, or to how to just look at which row sets and which columns are needed for any analytical queries later on. So this schema that is used is embedded at the end as part of the metadata, and it's a very, very efficient and compressed method of storing lots of data as it comes in onto the data lake. Do you have anything to add there, Tom?
No.
No? Okay, good.
Everything is said.
All right, so one of the things that we're talking about, so that's just Apache Parquet. Okay, now Delta Lake is laid on top of that and extends the capabilities of Parquet. And it allows us to use, as I said before, some of these relational database semantics. Okay, namely, when we're talking about relational database semantics, we're talking about ACID. ACID are a set of properties that are put onto relational or operational data stores, mainly to have helped in the past for things around concurrency, atomicity, atomicity, consistency, isolation, and durability. We'll talk about that in a second. But why would we even need that when we're talking about analytical data stores and batch processing for us? So the first thing is that traditionally, data warehouses are structured. Okay, so we have, as you might already know, dimensions and facts, and those were generally batches of data that would come in after either a number of hours, after a day, etc., and you would basically bring that stuff into your data warehouse. And they would also then be used for aggregations and complex queries that are being used later on for your analytics workloads. These batches would be processed generally offline because of the resources needed, and because it would be very hard to do these sort of things while other people are using the system. Okay, so as we said, batches were generally done in larger batches rather than smaller granular sort of batches themselves. Transformations, and when we're looking at cloud, ETL has been transformed or evolved into ELT or ELTL, which is extract, load, transform, or extract, load, transform, load, where data continues to start moving through the system. Okay, so very importantly, because we don't put heavy data structures in place at the beginning, we want that data to come onto the data lake first, and then we start to manipulate and enhance that data as we move forward. Now, as these things happen, we find that some changes need to be made. For example, historically, someone might call up the GDPR rights that they have and say that I want it to be forgotten. And so the data that we have and that we're transforming through the process for it to be ready for analytics might need to be manipulated and adjusted as time goes past. So what that means is that we need to start putting processes in place and transformations in place to change the data that has arrived in our repositories, generally what we call raw or maybe bronze, depending on what different sort of architecture you're using for these changes. So that creates a couple of issues around it, because when we're talking about these loading and transformation processes, we find sometimes that the data might be malformed. We might be getting data that has a structure that might have changed, or with these processes that we're running, we might find that they're bringing up errors as we're trying to either delete data, anonymize data, transform in or actually enhance that data with other data sets as well that are from outside. So those things mean that we start to put a lot of other processes in place, checks and balances, retries, etc., in order to get these things moving. So that might mean that we're blocked, or we're having to spend time manually adjusting things or manually recoding and adjusting a lot of these processes programmatically. The other point is, which is the third one here, is that in the industry we found as big data and analytical workloads evolved, that we were having different needs that are being requested in the environments. As systems became faster, as our storage and compute systems became detached and working asynchronously so that you can actually scale things out as necessary. Sure, Tom. The other conflicting requirements were basically that we had to in some cases, start reporting on historical data trends, which is the standard way of analytics, but also understanding or analyzing what some of the real-time things that were happening on the platform. So these real-time versus historical analytical workloads started to cause some conflicts in terms of how to handle that. So this was generally achieved through two architecture methodologies called Lambda and Kappa. Basically, you can look those things up. They're sort of out of scope of what we're talking about now. But those sort of things needed a way to be better addressed. And Delta Lake helps us with those sort of things. The last thing here is that when we're talking about data warehouses, that's structured data sitting on top of larger data sets. So when we're talking about data lake, we can have all sorts of files in there, be it non-structured, semi-structured, or even now structured, where you can actually define structures in the files, as we said, Parquet allows us to do, but also allows us then to do other things and look for other capabilities that we want to try to get out of the Delta Lake itself. So these are those 4 properties that I mentioned about, which were coming from the old school sort of operational data stores. And the areas that we were trying to resolve, okay, these system problems, as we would call them, are basically that on the data lake, we had no atomicity. So when you would run a distributed computation, if the job fails in the middle, you still have some partial results out there, and it's not all or nothing. And that's what we need. So atomicity basically means that if a job runs, it either completes or finishes correctly, or if anything goes wrong, it completely rolls back and nothing happens. So now with Delta Lake, you no longer leave your data in a corrupt state where you have to basically go in and tediously rebuild those data sets or use other tools to try to manually recover the data. Things are either there or not there, and you can retry it from the beginning of that step or not. One of the other key problems is that, which is fixed by ACID, is that there was no quality enforcement. So it was up to you in every job to manually check the quality of the data that was coming in against all of your assumptions. So there's no help from the system from that perspective. And if there are variants in the traditional data that was coming in, like what we used to have in our traditional databases, you could say, no, I don't want this data because the columns don't actually align with what I was expecting, and these sorts of things. So that sort of thing is now covered by this, by having the ability to apply a schema to it. And all that sort of stuff is kind of left up to you without these sort of ACID properties that we've got now. And then finally, there were no controls over consistency or isolation in the platform, in the data lake. And that meant that you could really only do one write operation to any data lake table at a time. And that made it very difficult to mix streaming and batch processes, which we were talking about with Lambda and Kappa, to do these operations while people were still using the data or trying to read from it. So in that case, your reports and your visuals might look different over time because of these changes that were being made. So all of these things were things that you would expect to be handled by your storage subsystem, and like they are in relational databases. And so what this brings to the table is that capability and some other capabilities as well as a result of having that. And the way that it does it is by implementing a transaction log. So let's take a look at this Parquet.
So before that, Charlie, I want to chime in for, please excuse me. I want to answer a question that was asked by Messias K on the chat, asking about or mentioning that Power BI or an analysis services tabular format was introducing this columnar format. Mm-hmm. And so there's still, we have still this Parquet format, and with all these data on top of Parquet format, we now have a columnar format that is supporting the relational asset transaction system thingies. So this is good. This is coming with Delta Parquet or Delta tables or whatever sometimes it's called. But now the question is about in-memory or things like that. Talking about this means there's this new connection mode that is called direct lake. So Vertipack and basically all the compute engines have been enabled by Microsoft that they are able to natively read data Parquet file formats. So this is really great. But also there's still some caching involved. So meaning that using this new import mode, this new connection mode, direct lake is also as fast as import mode. So we do not have to change things. Basically, this transaction basically it's almost as fast as native import mode. So this is good. And there was also a different question: what makes the file format, the Parquet file format, faster than other file formats? So basically, yes, it's stored as a file, but don't think of it as a CSV file or a text file. It's basically the storage layer. And this so if you have the SQL background, it's like MDF. It's the Parquet format or the Parquet part, and then the LDF is the transaction log. So it's more than a simple file, and because of its columnar structure, it's optimized for answering analytical questions. So hopefully this helps to answer things. And then there's also a question regarding when should we use more advanced ETL, ELT processes. So this is basically one of the benefits of using Spark for data engineering because of its built-in parallel scaling for transforming data. So the difference between data format and the data table and Parquet. So this is, as always, this is not this. These are so Parquet is the columnar format. Delta data table is still using a Parquet format, but is adding the transactional thing. So, and then sometimes people call this, like I do, a delta table. So maybe this is not that correct. Basically, it would be, considering Fabric, it would be better to use the delta Parquet because we are using Parquet as the data storage, and delta is adding this transactional things. So it's always the same, but different terminology or different words are used for the same thing. So this can be confusing. So I try to, for the rest of this show, I try to use delta Parquet, but I cannot exactly promise that this will work out, especially not when I'm in the exercise.
Same here. We get the terms sometimes mixed up in terms of how we use them, but yes. I think it's generally quite clear in terms of what we're looking for. And exactly as Tom said, Delta Parquet format is basically the capability of having a transaction log, which is what all those relational data stores did in order to get some of these ACID capabilities. So the transaction log in SQL, in Oracle, in all the different database management systems allows us to maintain durability, allows us to maintain row versions of different data that's actually being updated so that we can maintain concurrency and these sorts of things. So what is it? From what Tom was saying, just to extend on what he said, we have that Parquet format. And then when you enable Delta on top of it, it creates a folder here. Oh, and I think it's going to push me that way. Sorry. Try again. It creates a folder on there. And instead of it being a transaction log, it's a number of files that get created with each of those changes that are being read, that are being written. So these data files themselves are the data that's coming in. And then this delta log directory maintains these things in JSON, so that there's been a create, that there's been a change, and these are the changes that occurred on the files or on the data set that's already in there, etc., etc., etc. Now, this can be difficult then to keep track of, and this can end up slowing down the platform because of the number of files that might be coming through. So that's why alongside this capability, there are checkpoint files, and checkpoint files generally aggregate a number of changes that have occurred and puts a checkpoint file which addresses X number of changes that have occurred, so that you have then, and that's in JSON format, that's in Parquet format, which allows them to say, okay, consolidated changes that are happening throughout are here, and that if I want to do a time travel to a certain point of time, all I need to do is to go to that checkpoint file and understand what the changes were or what the delta has been between one change or one set of changes and another over time. So that's basically what it is. It's basically adding transaction log capabilities within the capabilities on top of Parquet files. Okay, and it's a mix of continuing to use Parquet and using these JSON files to actually describe what changes have occurred over time. And that then allows us to have these capabilities from ACID transactions, updates and merges to the Parquet data, or to the data that's in the data lake itself, the versioning and the time travel, moving back in time and versioning that data as well, so that we know how to address or how to get to certain changes there as well. So things such as slowly changing dimensions, to additions to the fact tables, as we would see them in traditional data warehouses, etc., would be managed in that capability too. Additionally to that, it says here schema evolution, so that would actually be something that would be logged in there. So if you end up adding columns, removing them, removing data, etc., that would then be managed there as well. Okay, so that's the basic understanding of what Delta Parquet format adds to the Parquet capability itself. So now we're going to talk a little bit about creating Delta tables. Tom, do you want to take us through some of this?
Yes, please. So when a delta table is stored, so being precise, it's not a delta table, it's a delta Parquet item. And this is represented as a table inside Fabric. So, and now if you're going, so this is what the second bullet point is pointing out. And so then it's also essential to understand that there is a managed table and an external table. So basically this is, Fabric also comes with, or the most, from my point of view, the greatest amazing thing is this one lake thing. And one lake is, let's say, an ADLFS based Gen 2 based data lake that is completely managed by Fabric. And this one lake and stores the data. So it's like the hard drive in your machine, and then it's this managed table, external tables is about who is creating these tables. If I'm creating this table from inside my Spark environment or my Spark lakehouse, then it's called a managed table. On the other hand, so it's an external table, for example, if other teams are able to create these data tables by adding these data tables or writing these data tables into the underlying ADLS Gen 2, meaning the folder, the location. So, and this is where basically the difference. So, and managed by Fabric Spark means it first appears in the tables directory, And there we are also able to have a closer look at the available Parquet files and the log file, the data log file. And this is something I will showcase also during the exercise. So, and then there's, if I'm creating an external table, the user is able to, or I am able to provide the location. And when, so data is, when I do something like drop table, then I'm dropping data as well. So this is different from when I'm dropping a table that is external. So, so this means data is retained, but still only in the file folder. So this data retention thing, this does not make external tables better than managed tables. You should only use, maybe there will be, sometime in the future I will change my mind. Maybe you should use external tables only if other teams outside of, if you are using Fabric, then there's a Fabric workspace, you will see this, and I always consider a workspace as a solution. And if the team that is building the solution is creating the data tables, then I recommend using managed tables. But if this solution is based by many different teams and these different teams create different data tables, maybe then it's a good idea to use external tables. So, and with this said, integration with other tools, basically all tools that I can provide access to can reuse these tables. And external tables are maybe a little bit more open, but we also have, of course, to consider if we want this to be more open, because it's just a data table residing inside a folder in my ADLS Gen 2 storage account. So for this reason, maybe this helps us to, or maybe helps you to decide manage tables, external tables. No matter what, ACID transaction batch streaming is supported for both kind of themes. It's performance-wise, it's very similar.
Mm-hmm. Yes. Great. So if I basically summarize or try to see what I understood from what you were saying there, Tom, there are two types of tables, managed and external. The main difference that I like to see, coming from a relational background, is whether or not maybe we've got a table with a clustered index on there, okay, which is the physical representation which you might have created inside the Fabric environment. So you're creating it manually with the structure and the data in there, etc., is there, and it's stored within Fabric. So Fabric itself manages that sort of data, so that if you drop it, then you're dropping not only the reference to it, but also the data itself. Okay, so if that's, did I understand that correctly from you there, in terms of the managed tables, Tom?
Yes.
Okay, brilliant. And then how I like to relate to the external tables is maybe creating a view on top of your data, right? So the data is in a table if it's on a relational data store, and when you create a view to it, you're accessing it like it's a table for analytics and so forth, but it's not actually the definition, or the definition is closely associated, but it's not actually bounded to it per se. So because it's managed externally,
this comparison is a little bit philosophical,
sure,
because both delta tables, no matter what, are delta Parquet files or delta Parquet somethings, and are representing a table. The difference is that an external table is not managed by the Spark engine. It's used by Spark. For this reason, it's a little bit different than a view.
Okay, brilliant. But then the additional capability there is that if you do, as you said, delete or drop a table that is external, that the data still resides there and won't be touched anyway by the perspective, unless you go into the files.
I will showcase what happens if I'm dropping and what remains also in the exercise.
Brilliant. Okay, so from that now, let's take a look at how we would work with those tables.
So basically, what's coming is I will highlight this more in the exercise. So how can managed tables be created? Yes, so this is, here we see I can from a schema. So a schema thing is also a very important thing because of data types, not null, null, things like that. And basically, you also can see how this works with external tables, but I will, as I already mentioned, I will demonstrate how different languages can be used from inside an external table. Yeah. So please go ahead, Charlie.
Sure. So that's the next section, is actually working with these tables in Spark using code. And I think Tom's going to talk us through some of these code segments and also within the demonstration of the exercise as well.
So this is also a thing that we will see a little. So what we are seeing here is Python. And first, there's this variable on the left from called df tenant settings, JSON, because I say it's a data frame based on the JSON here. So, and then there's something that can be considered a Spark data frame based on JSON files given in a certain directory. Thank you for highlighting this. So, and then the second line, I use the method this column on top of the existing already as existing data frame, adding some housekeeping columns in this example. Oh, and then, as you also can see, it's possible to use different functions. So the last line of the this column file date, I'm extracting using a specific function that is available from inside Spark. I'm extracting a date and then I cast from a file name and then I cast it as a date. So, and then finally the third line, this JSON.write, I'm saying I am writing this data frame to my lakehouse. This is the last command, save as table. And I say, of course, I want to use the format delta. And the mode that I'm using here says I want to overwrite this file. There are also a different
like append,
right? For example, append. I'm adding this, so I'm adding new data. This can also be done, and this is pure PySpark, where I'm creating my delta tables or delta Parquet files. Oh, I'm creating delta tables based on Parquet file format because I'm using the format delta in the last setting. So, and then there's also, I can also do something that, if I'm not that familiar, I can also use Spark SQL. I do not have to use Python if I want to do something. I also can use plain SQL, and this plain SQL is in the second box here, SQL in a notebook. And if you're not currently not familiar with notebooks, I will showcase this during the exercise. I can use this %% called magic %% SQL tells the execution engine of the notebook now, next, there's pure SQL code coming.
Mhm.
So this
Not
is
necessarily T-SQL, right? It's just it's another variant of SQL.
this is Spark SQL because I'm using a Spark. This is currently not SQL, but not T-SQL. This is basically
another variant.
Spark SQL. So, but basically they are SQL ISO compliant. It's not that a big difference. So basically what makes it a difference is this magic, and then that my cell now contains SQL code. And I can create another cell and use, for example, Python again.
Great.
Yeah.
Okay, so then the differences between that and the Delta API, I guess.
So, and here I'm more or less doing updates using the Delta API. Also, once again, I'm using PySpark. So you can decide what you want to use. This is also about how familiar you are with SQL or how familiar you are with Python and things like that. I have to admit that I love using PySpark instead of SQL. But if I'm looking sometimes at the PySpark code examples, they are not that beautiful as SQL. But I have the idea that if I'm using Spark and Python, I have more control over everything. So, but maybe I err. So, and please go to the next slide. So this is also something that we will see in the exercise. Here you see what is stored in the log file, the JSON log file. You see someone or some time the table was created. Then there was a write statement, append, and then something was updated. And this is exactly what is more or less is stored in the log file.
JSON transaction log, right? Yeah.
Yes, exactly. So this, I will also showcase this. And here we can see different versions of using PySpark to read data from a table and at a specific given time. Or the second example, show me the initial version. Please keep in mind that this versioning is, if you are working with financial people, they often want to have snapshots of their data. You can use these versions to create maybe your own type of snapshots, but it's more or less also a good idea to be aware of this versioning if you realize that your business or business is telling you, whoa, we forgot to tell you that at the beginning of the year the business logic was has changed. So, and now you have hundreds of millions of records, and the business logic to create, for example, a given column has changed on the beginning of this year. So what do you do? So, and then you can say, okay, I use all the data until the end of last year, keep it. And then I use a different type of code to create the column value for starting with the beginning of the year. So this is also something what time travel enables you. You do not have to load all these 100 million rows of data once again. You just can focus on the last increment. Yeah.
Great. So I think these options here are things that you'll probably be highlighting as well, but they're very important to understand that it's the same sort of query, just with a different option setting on whether you're going to use a date time or whether you're going to use a version number here. So brilliant. Okay. So I'm actually going to jump in now too, Tom, and talk a little bit about streaming. I mentioned before these different methodologies in terms of analytics, where you would actually get data from either streaming data sources when you want near real-time analytics, or from historical data where you want aggregations and things done from there. But with Spark, we've got the capability of having structured streaming, and streaming happens in that sort of an approach. We've got small batches of data coming in. They basically serve as the input. They get worked on through the Spark engine in this case, and then we do some process or some aggregations or manipulations on top of it, and either write out a query, write out the details, or maybe even write it back to another process itself. So the code that we use in terms of delta tables for streaming sources here are basically the same sort of thing, which again, Tom will go through. But we firstly import those libraries, we set a data frame, and within that data frame, we say we're going to be reading a stream, a Spark stream, and it's in delta format. We say that we're going to ignore any changes, and this is the location that we're getting it from. Okay, and what we do then, the next step is to start the stream. Okay, afterwards, sorry, the start isn't on there, but in this case, it's very simple. We're just showing the data from the stream itself. So that's taking data from an input stream, similar to what you would have done in the Lambda or Kappa architectures. And what we can also do through the delta format or these delta tables is similarly, we've got the import, and we've got the import part, which we discussed before, just now. And then we're going to say, okay, we're going to need a path for the output, and yes, the checkpoint path, because we're dealing with delta. And then we're saying that we're going to be writing that stream to a location. In this case, it's going to be a delta table path, okay? After it's finished, then we can stop the delta stream and things are there. So what that is basically saying is that we can have delta streams coming in, or streams coming in using delta in, and writing them out as well, with those operations and processes on top of those as we write.
This is also what we will see in the exercise or in the live demo.
Brilliant. And perfect timing. We're actually going to start on the exercise. Over to you then, Tom.
Okay, thank you very much, Charlie. So what you see here is more or less the first command if you are following this exercise. And this live demonstration is not intended that you are doing exactly the same thing at the same time. So this is, I'm going through this, and on the Microsoft Fabric homepage, select Synapse Data Engineering, and this is where I'm currently now. And from here, I'm selecting the Synapse Data Engineering part. And then I go to Workspaces. I create a new workspace and call this live demo. So because we are talking about Fabric, and this is more or less, if you're familiar with Power BI, this is about Power BI workspace is now called Fabric because now these workspaces, these Fabric workspaces have additional capabilities. For this reason, it's very important that if you create a workspace, that you have to use a licensing mode that is supporting these Fabric workloads. And I am saying I'm using a Fabric capacity, and this is my capacity that is Fabric enabled. And now I create this workspace called Live Demo. Hit apply. And here we are in my workspace. And now we need for example, we need this lakehouse. I just go here because not sure if you already have seen this. This is, let's say, provides different views. And I'm here in the data engineering view now. And this allows me from the new, I can exactly create my lakehouse. And I also call this live demo and add 2 characters for lakehouse. And now I'm creating my lakehouse and I'm good to go. So this is my lakehouse. It's called live demo. It says tables. I refresh it and most probably it will appear that they are empty. So for this reason, there was also a question if there's live or demo data. Yes, for this little exercise, there's demo data available. And I can upload these because I already downloaded it because of the timing for this live stream. So this is the product's CSV file that is used for this little demonstration. And whenever you do this, don't forget to hit upload. I do not know. I did this 10 times, and I guess 2 to 3 times I forgot to upload and was wondering where my file is. So now I uploaded it. It tells me it was uploaded. And now I can go here, go for up files, and refresh. I forgot something. I forgot to create these specific subfolder. For this reason, I will delete it because otherwise my first I create a new subfolder in my files section and call it products. So I'm a little bit happy that I have prepared something. So uploads, and I create my product or select my products file once again. And do not forget to upload the files folder. Hit the upload section. And now I have my products CSV file. So this is what I'm currently have. I have a CSV file in the file section of my table of my lakehouse. And I refresh the table section. Of course, it's empty. Now, because
so you could actually look
about
at that products file, couldn't you, Tom? You could look into that products file from here as well, or not really?
What was the question? Please excuse me.
Is it there as a file, or can you also look at the contents within it? Does it bring it up as a table format? If you look into the
products, I can do so if I'm load to tables. But this is I can do so, but I cannot look from inside the lakehouse. I cannot view files. A lakehouse. So the lakehouse is some kind of database, and it's not a file viewer. So, and for this reason, to work with with files or with data at all, here in this section, in this episode, we are focusing on using notebooks for this. So, and I create a new notebook. And now fetching metadata, loading. And now I see I have a notebook called 1. And then there's a resource folder where you can store additional resources that you may want to use with this specific notebook. And now I added a notebook from inside the content of my lake, or from the context of my lakehouse. And for this reason, this lakehouse has been assigned to this notebook as the default lakehouse that should be used with this notebook. This is always a good idea, but and now what would happen is I go to all these exercises, do copy and pasting. This is something that I want to avoid because otherwise I would be confused. And for this reason, I prepared something, and this is also something that I recommend because this great what is possible is, now I have this notebook here. Now I'm looking at my workspace, and if I'm looking at new, there's this import notebook item. And what I really love about notebooks is, I'm not sure if you're familiar with notebooks, but it contains code. And now I have my notebook that is working with delta tables. And now I have this notebook open. So sometimes it can be a little bit overwhelming, or all these panes, and you can use this little double arrow closing these things. And now I have my notebook, and now you see, instead of the demo that I created, I do not have a lakehouse assigned. I can do this by adding a default lakehouse, and I use my existing one. And guess what? It's the live demo LH doing this. Now I see that my lakehouse appears here, and I have my product file. And now I want to explore the content of my CSV file. And for this reason, I have this load data, and now I want to use Spark. And then it adds a cell. And what you see, if you're not familiar with notebooks, now if you hover over these items, you see that this code thingy appears, or this markdown thingy appears. A code cell, this is a code cell, contains executable stuff. A markdown cell like this one contains only comments. So this means, and if I'm a little bit familiar with, go away.
Markdown, yeah.
Go away somewhere. So I can use some certain, this means this is header 1, and then I can type here, and what is this? And also can correct my typing. I have a cell, a markdown cell. And this markdown cells also have the possibility to get expanded or collapsed. And now all these level 1 headings are representing sections from the exercise. And I already prepared this. And now I say here, read the data Spark, the CSV file from the options, do this. And then as my second command, display this.
Data frame, yep.
Display my data frame. So, and this is also something that I love. I call this a variable object type, things like that. It's called data frame. And now you see what is inside my data frame, because I used this.
So that's bringing up a CSV file in a format that you can see is basically like a table, yes, with row numbers and stuff like that too.
And now I want to, from this data frame, I want to create my delta table. And I use this variable from here. And now I say, write it, use the data format as table manage products. I do this. Now this will take a couple of seconds, because now Spark cluster is started, and this may take a couple of seconds, 11 or 12 seconds.
This is a managed table then, right, Tom, rather than an external
this
table?
will become a managed table because the source is a data frame, and I do not specify any location or things like that. Brilliant. So now it's done. And now if I'm refresh this here, I have my managed products. The context that how I'm currently looking at this lakehouse, or at the content of this lakehouse, is the context of the notebook. If I change the context, meaning now I'm not looking at the lakehouse, I also can go for my table and loading a preview. This was in one of the first slides about delta tables, and here we are. So this is my simple table, but now I'm going back to the context of the notebook. So, and now I'm creating an external table, some notes. So this is also good for explaining your code, documenting your code. These markdown things I love notebooks. I have to admit that. And what it says here, a new subfolder in the file section will be created. And I also have to use please forgive me, using this starting code that is also in the exercise. I'm too stupid to copy things. This looks okayish. So, and what this node is also as in the replace the ABFS parse. The ABFS parse is, I get this from the file section and get copy ABFS parse. And then I can replace it. And of course, I have to remove my command cell. And now I'm writing I create a table called external products. And if it's done, I can refresh my, it's still running. So now I have my external products, and this is an external table. And now I can compare these two different table types. And this is the magic I mentioned, is about SQL.
Mm-hmm. And so the describe thing is a special...
what happens? Sorry. So now I see that I have some kind of information about my table. It tells me the type is managed. If I'm running this cell, now it's external products. It tells me it's external.
And it tells you the location. So that's cool.
And it's also a little bit a different location. So here I see this is my storage account that is used. And if I'm looking at this location, we will see fancy numbers. And these fancy numbers, for example, is the ID of my workspace. And this is the ID of the lakehouse inside my workspace. So instead of using, if I'm looking at this, here I am at the storage account of my workspace because I pretended, or I created an external table. And now if I'm doing this, I have two tables. So if you're wondering why this external products table appeared without creating or saying explicitly save as table, it's because this folder contains a delta table or delta Parquet file. So closing this once again, now I'm dropping these files. So, and if I refresh this, then no tables. If I refresh my files section, it's still there. So this is products. Of course, products is there because it's based on the CSV file, and this is an external table, and it doesn't, if I drop the table, the external underlying data will not be deleted. Now I can use also, once again, using SQL to create my table. And this will also create an external table because I'm using a location from a products. So, and I'm just executing the next cell because I did this. Now you see I have my tables, and if I'm refreshing my tables section, it's also very good. So and now we have some kind of versioning. Look at this. So now I'm once again using SQL to update the products, the list price of products from the category mountain bikes. Doing this. This is basically a simple SQL statement as you know it from SQL Server or other SQL environments. I see how many statements or rows have been affected. And now I can inspect, for example, the history of the products table. So here I see the version. I see it's updated, version 1. There was an update statement, exactly what would be stored inside the transaction log. And version null is basically the beginning. And also here I see that I'm now looking at version 0 and just a data table without any version. So this means if I'm not specifying any options like version as of, I'm seeing the current data. And here we see product ID 771 with this price. And if I'm scrolling down a little bit, now 771 version 1 after the update, the same product with a different price. So this is how I can maybe use or for these version things. So and now we do some streaming data. Streaming data, maybe you all think about, or we all think about IoT devices, but in this example, it's when, or yes, as soon as a file enters a folder, it will trigger an event and streaming event. So now I'm setting this up. For this, I use some notebooks, some Python packages, and I will do this. and it looks like it has worked out exactly. And now I go here, and here I have my data text, the first thing that I wrote. And now I am enabling the stream, and here the streaming was done. And now I can select my data from a table that was implicitly created based on this command, and also because that we are writing this text file as IoT device data. So now I see I have 9 rows in my table. And now if you are wondering what is the magic of this streaming, so I love the idea of using streaming as when a new log arrives inside a folder, do something. And now I'm pretending with this cell that new data has arrived in this folder. And if I refresh this folder, we will see now there's a second text file. And if I'm going back a little and read my new table that basically appeared here, if I'm requerying it again, it has more than 9 tables because now it shows everything. So this is sad. We are the more or less last cell is I'm stopping the data stream. Doing this whenever now this data folder contains or more text files are enabled, these will not be reflected automatically inside. If I would use this, it would not be reflected. I have to enable it again by executing this section here again. So, and with that, I'm done with my exercise.
Great. So Tom showed us lots of different things. Go ahead, please.
If you are having extra fabric capacity just for your exercise, do not forget to pause the fabric capacity if you are going on 4 weeks of vacation, and do not stop this. You're paying money. And otherwise, if you are using the production fabric capacity, maybe your fabric workspace admin is wondering what is going on. So with this said, happy to do this. Hopefully it provided you some insights. Yes. Great.
So in your exercise there in the demo there, Tom, you imported some data into the data lake. You created some managed tables from there. You also created some external references to some external tables. And then from there, you were able from there also to create some managed tables from the external. And then you showed what happened when you dropped them, and including the streaming capabilities there too. So a lot was covered in there. Thank you very much, Tom. And so now we can go into the summary. So what we covered today was understanding Delta Lake and Delta Lake tables. We talked about why they're important and why we've actually got them in our analytical workloads. We looked at how to manipulate those things using Spark and encoding practices there too. And then we transformed some data. We looked at some of those and how it looked inside the Delta Lake tables, and we looked at the format as well that's on the inside the one lake. And then we looked at a quick glimpse in terms of how structured Spark streaming happens too. Now, at this time, I just want to say a very quick thank you to our moderators, Nikki and Bernard, for moderating, fielding a lot of questions from what we could see as well there. And Matt and Jed, thank you very much for helping us on the production side for the live stream. We had a couple of questions, Tom. Would it be okay with you if I brought some of those questions up and see how we can answer them?
Of course, of course.
Cool. So one of those questions is, can we keep petitions from Chiranjib asked, can we keep petition Parquet files in the root folder? Is it possible, or is it just the best practice to put them into other folders for Delta Lake?
So I would say best practice is put them into different folders.
I agree. Putting them in there is putting them in the root makes it into a bit of a data swamp in the end, I think, later on. And another one is, can external tables be updated? What happens when you change the structure? And this is a question
an external table is not a view. An external table is a table that was created with the responsibility of someone else. Meaning I am allowed to write delta tables into this file section called external products. And yes, I can update these external tables as I can update managed tables. And so basically, it also supports schema merge or things like that. It's a different table. No, only the location is a little bit different, even if it's stored in one lake. But the main difference is the responsibility who created these files. So this is the main difference.
Great, between the external and the managed tables. Brilliant. We have another question here. We've got a couple of minutes left on the call, on the live stream. Thirumal asks, is there a way to get historical data of a particular row? So versioning basically of different versions of the same row.
Sure. It's just a select providing the option which version, and then you have to filter if your table contains a billion of rows and you want to see all the version of a single row, then you have to be able to filter down for this single row. But yes.
Brilliant. Okay, and we have probably 3 minutes left, so we've got time for one more question. Mike is asking, is there a way to access the output from a magic SQL cell in a PySpark data frame in another cell?
So it's not that simple, because you cannot directly access the result, because a magic SQL does not provide, it creates something in your lakehouse or drops something from your lakehouse, but it does not store something in a variable. So it's not that simple. It requires you to do something that is, let's say, wizardry level 500 using notebooks. I would not do that. If you want to use SQL to do something, to alter something, do this using Magic SQL, and then just start the next cell with reading from your data table.
Okay, brilliant. So once again, as we conclude, thank you very much to our moderators, Nikki and Bernard, for helping out in the background with all of your questions. And Jed and Matt, thank you very much for your production help there as well. So to everyone on the call, everyone on the live stream, thank you very much. Great to see you, and hopefully you go really well with your exams.
Yep.
Cheers.
So then, thank you, everyone. Thank you.